Hey guys, happy Friday. Today's lesson is going to be a fairly simple one, especially compared to some of the other ones that we've been working on, and it is entitled The Discriminant. And it's actually a little bit of a continuation from yesterday's lesson using the quadratic formula. So the quadratic formula is up here. The discriminant is the part of the quadratic formula that we find under the square root. And the reason that we need, well, not need, but it's helpful to use only that part is that gives us an idea of how many roots there are, so how many answers, just depending on what we get under there. So we have three possibilities. The discriminant can be greater than 0. It can be less than 0, or it can be equal to 0. So what this does, like I said, is it just allows us to figure out how many solutions there are to the quadratic equation. Instead of plugging it in, it doesn't tell us what the solutions are, but it tells us how many and what kinds there are. So what we need here, so this is the discriminant, so I need a number that's less than 0. So any negative number, let's go with -7. So if we end up with a -7 under the square root symbol, what does that mean when it comes to taking the square root of a negative number? Well, we know that's not a possibility, right? So what does that mean? Well, there are clearly no solutions to that. So we say no real roots. So if you end up calculating the discriminant, end up with a negative number, you would say no real roots. So a couple of possibilities here, though, when it comes to being greater than 0. So the first one we have is if the discriminant is a perfect square. So let's just come up with a perfect square. I'll just say a 4. Well, we know that no matter what's here and no matter what's here, when we take plus or minus of a square root of a perfect square, we're going to end up with a natural number here, right? And so it doesn't matter. Once we work this out, we'll end up with 2 answers, of course, because of the plus or minus. 2, and from what set of numbers? Well, they will be rational because we won't end up with an unsimplified radical. We'll take, for example, the square root of 4, and we'll get a plus or minus 2. So 2 of 2 rational roots. There we go. And if it's greater than 0 but is not a perfect square, let's say I'm going to go with 8. So we're going to end up with plus or minus root 8. Well, we can simplify that. Break it down into the square root of 4 times the square root of 2, which is 2 root 2. So we'll still have 2 possibilities, but they won't be rational. They will be irrational. 2 irrational roots. And then last but not least, of course, if it's equal to 0, then it has to be 0. Well, when we have plus or minus the square root of 0, we only end up with 1, right? Because we know that 0 is neither positive nor negative. And so this time there will be only 1 rational root. So when it comes to the graphs, and this is just to make it a little bit more visual. So when we end up with a discriminant that's less than 0, we know that there will not be any real roots, and so that means that the graph will not cross the x-axis because we know that the x-intercepts are the roots or the answers. So these are just randomly drawn parabolas, of course, For example, like that, where, and I mean this could be over here, this could be over here, but because it doesn't cross the x-axis, there are no solutions. If it's equal to 0, then we know that the only solution it could possibly have is if its vertex was on the x-axis. Oh, didn't quite make it. There we go. And then if it's greater than 0, we know it has 2 roots. And so it would look something like, oh, that's not a good parabola, but you get my point, where it would have 2 x-intercepts, right? Because those, again, are our solutions. So not necessary to identify the ABC values unless you find it useful. So it says calculate the discriminant to determine the number and nature of the roots. And memory serves, I think, what I remember is students, well, sometimes we'll solve, which I'm not interested in, and then they will tell me that x equals. We can't do that. We're not solving because we're only using this part of the formula. So we are just calculating the discriminant. So what I use for that is just D equals, capital D for discriminant. And we don't take the square root. We don't need that at all. We just need to know the value of what it is. So I find it helpful to set it up like this. But I wouldn't require that. Negative 5 squared. Watch, you got to put it in brackets, because not putting it in brackets, if you didn't have the brackets here, it would end up being negative 25. But because it's in brackets, negative 5 is part of the base. So negative 5 times negative 5 is 25. I don't need any more than that. You can type that in. 25 minus 16, right, that's 9. And so obviously that's greater than 0. It is also a perfect square, and we can just see it up there, so we know that it would have 2 rational roots. And super important before we calculate the discriminant to make sure that we make the equation equal to 0. So adding 9 to both sides, and D equals. And the only thing I think I found with this is sometimes students will put the wrong value, which is why I, suggest A, B, C. I didn't for this one, of course. So 64, 4 times 9 times 2 is 72. So 64 minus 72 is negative 8. Well, we know that when we try to take the square root of a negative number, it doesn't work. So we end up with no real roots. And that's today's lesson. We have verifying, error analysis, and problem solving left. And of course, we're a little bit behind, but what I'm going to try to do for the rest of the school year is just really zero in on what I think the key components are for Pre-Calc 30, and do my best to get everything taught. So I'll attach the assignment with answers. Feel free to ask any questions if you have. Have a good weekend, and we'll talk to you on Monday. Bye.